In this first problem, we're going through and taking a look at the sampling distribution for the statistics of the mean and the standard deviation from this small population consisting of the values 2, 5, and 7. In this problem here, all samples of size 2 have been drawn with replacement from the small population of 3 values. The reason for doing this is that sampling with replacement goes through and simulates an infinitely large population, and by taking a look at the sampling distributions here, we'll be able to determine which sample statistics help estimate population parameters. So what we want to do first here is treat these 9 rows containing 2 values as individual samples. And so let's go through and compute the sample mean x bar first. And so the sample mean x bar is found by taking the sum of all of the values and dividing by n, the number of values in there. And so for the first value here, we've got 2 and 2, so it's 2 plus 2 is 4. 4 divided by 2 will go through and give us 2. Similarly, we've got 2 plus 5 gives us 7. Divide 7 by 2, and we get 3.5. So on and so forth, we can go through and compute all of the means. So now we have the sampling distribution of the means laid out. Now let's go through and take the mean of all of these sample stats. So we're going to take these 9 values, add them all together, and divide by 9 to take their mean. And in doing so, we get 14 thirds, which rounds off to 4.667. Next, what we want to do is take a look at the population parameter and see what that's equal to. And so the population parameter here is mu instead of x bar. X bar goes for the sample, but for the population, we use mu to represent the mean. And the difference here is that we have our formula now using mu and capital N to represent the population size versus lowercase n, the sample size. And so if we go through and add the 2 plus 5 plus 7 together and divide by 3, we get 14 thirds, which is the same thing as 4.667, just rounded off to 3 decimal places. And so we can see here that by taking the mean of all of the sample means, we ended up with the population mean. And so that's telling us here that the mean is an unbiased estimator. We can use sample means to come up with an unbiased estimate of the population parameter. Next, let's do the same thing here for standard deviation. The formula for standard deviation S here involves us taking the squares of the mean subtracted from every data point, added together, and then divided by the sample size minus 1. And so if we go through and were to take the values 2 and 2, well, since these values do not vary at all, there would be no variance. We'd be able to see that the variance is just 0 because those values don't vary at all. The mean of them is 0, and so if we use this formula, we'll quickly find that it does equal 0. Computing the next value, we should be getting 2.121, and going on through here, we do have some repetition in samples throughout, so we do have some repeated values occurring, but we should end up with these 9 standard deviations. Next, what we want to do is take the mean of all of these standard deviations and see what we get. So we add them together, divide by 9, and I'm getting 1.571. Now to get the population parameter for the standard deviation, it's equal to sigma, and the formula for sigma is slightly different. Instead of dividing by n minus 1, we're going through and dividing by capital N. We don't go through and subtract 1. And going through and computing this, we're getting 2.055, which is a little bit different than what we got from using all of the sample stats. And so we say here that the standard deviation, trying to use the sample standard deviations to estimate the population parameter, does put some bias into the situation, but generally in practice, we go through and treat the standard deviation as an unbiased estimator because it is pretty close to the actual standard deviation. Now, The whole point of this exercise here is to help pave the way moving forward into chapters 8 and 9. When we're going through and doing hypothesis testing, we want to know which parameters we can do hypothesis tests on. Now, taking a look at a larger table here, we have all these sample stats like mean, median, range, variance, standard deviation, proportions. And they're going through and they're working with a population here of 125 versus 257. And they're doing the same thing here. They're sampling with replacement and then computing all of the various sample stats, then taking the mean of all of those sample stats, and then running through and determining the population parameters just based off the values 1, 2, 5, and comparing whether the sample stats go through and target the population parameter, and we find that for means that the population parameter is targeted. We find out for variance that the population parameter is targeted, and we find out for proportions that the population parameter is targeted by all of the sample stats. So what we're going to be doing is doing hypothesis tests, testing claims about mean, variance, and proportions. And we'll also include standard deviation as well. Even though it does put some bias in its estimate, the value is generally pretty close, and so it is accepted to use standard deviation as an unbiased estimator for hypothesis tests.